On the previous video, we talked about how base pairs are formed. You always have to have compatibility between hydrogen bond donors and acceptors, as we see here in this AT base pair. We also have to have a single purine and a single pyrimidine. That is, we have to have three bases that are kind of lined up in a row like that. And the reason for that is because we have 20 angstroms coming across here. It's got to be exactly the right distance across. We also touched on the major and the minor groove, but I really want to just get back to the idea of why these base pairs are interacting in this way. Let's move down and introduce the idea of what's called Chargaffs rules. This is a set of observations that were made by a scientist named Erwin Chargaff in the 1930s, a long time before the structure of DNA was determined. And he analyzed a bunch of DNA from different organisms, and he always found that there were certain patterns. And he found that if you looked at all of the bases, the percentage composition in any DNA molecule, you found that the percentage of A was equal to the percentage of T. Now we look back on that, and it's obvious why that's the case, because every time you have an A, it must be paired with a T. But in those days, they had no idea why that was or what it meant. He also found the percent G, as you might expect, is equal to the percentage of C for the same reason. G always goes with C. Then he found something interesting that was not obvious then and maybe not obvious to you now, and that is the percent in G of G and the percent of A was always equal to a particular number. Can you figure out what that number is? Maybe pause and see if you can think that through a little bit. What he found was if you added up G and A, it always turned out to be 50%. And many people realize that that's true, that 50% is also equal to the sum of C and T. Why is that? The answer is that because G and A, what do they have in common? They're purines. And what do C and T have in common? They are pyrimidines. So you can have a lot of C or a lot of T or whatever, but every base pair has to have one pyrimidine and one purine. And therefore, the pyrimidines as a group must all add up to 50%, and same with the purines. Now, this is interesting for one reason, and that is if you are given the percentage of any base in a double-stranded DNA, like for instance, if I said to you a particular DNA has 17% T, you can figure out all of the others through Chargaffs rules. Why don't you go ahead and see if you can figure that out. What are the other basis percentage using these rules? Pause for a moment. Well, we know that T and A have to be equal to each other, so that's easy enough. And we know that A and G have to match 50%, so that would be 33% for G, and C must be 33% as well. Like I said, if you know one, you can know them all, and that can be kind of handy. We'll practice that on the homework.